Hi, everyone, and thanks for joining. My name is Alexandra Fritzen, and today I will be talking about the benefits of visualizing graphs. Now, in previous trainings, you've learned about what a graph is, how to load your data into a graph, as well as how to, run analytics on your graph and the cool things you can learn from that. And today we're taking a little bit of a different approach and we're looking at how visualizing my graph can actually be very beneficial to me and maybe also to more novice, not technical users. So yes, my assumption today will be that you have already loaded a graph and you, you're trying to write queries to it. So as you can see on the top right, I have some simple tables. I'm going to assume you loaded them into a graph just like I did. And then you're starting to write queries to them, PGQL queries. Now I put a very simple one out here, which just gets all vertices and edges from my graph, since my graph is so small and I want to show you everything in the graph. You can see from the results, maybe I can highlight it here, that you get back a PGQL result set implementation. And that PGQL result set implementation contains all the query results that you need. So that contains what vertices do we have, what edges do we have, what properties do these vertices and edges have. And I can also see that there's actually 22 results. Now that's great and all, and you can use this PGQL result set implementation for purposes such as analytics and any programmatic interfacing with a graph query result. But for a novice user or someone who just wants to see, what actually they're querying now, this doesn't really help me very much. I don't know, just with this result, who's connected, how are they connected, why are they connected, is there something fishy going on, is there something interesting going on, and many more questions. And that's kind of what graph visualization tries to help you with. So imagine instead of getting that PGQL query result set implementation, you get back this blob of color on the right. So my vertices are circles and the edges are the lines between. That's a very big difference, right? And I'm here not to tell you the three things that I think you will gain from graph visualization, which is the thing on the right. First of all, understanding the relationships between your data points. Secondly, understanding property-based commonalities in your vertices and edges. And lastly, thirdly, actually giving you the ability to naturally explore the data that you have. So don't worry, I will be talking about each of these now in the next section. Firstly, understanding relationships between your data points. So by visualizing your graph, you can actually see exactly which vertices are connected. So you can see on the bottom, for example, you have, let's take the one on the bottom left, you can see, all right, we have these vertices and I can see, okay, some of them are connected, some only have outgoing edges, some only have incoming edges, and there's some interesting things that I can notice. For example, here I can see a circular dependency, so an outgoing edge from this vertex, and then another outgoing edge back to the original vertex. So that is a circle, of course a small one, but it is a circle. And I can also see, depending on the graph layout that I choose to visualize my graph in as, I can see, for example, the level of hierarchies. So with the hierarchical layout, I can see, all right, there's actually 4 levels of outgoing edges or vertices, I guess. And with the radial layout, I can see, for example, what are some vertices that are kind of hotspots or that are highly frequented. So that would be the one in the bottom right, for example. And just by visualizing your data like this, without actually knowing what these vertices are about, you already understand more about your data. And you have some maybe things that you think are more interesting now. Maybe you want to check out that circular flow, or you want to look at that 4-level hierarchy, things like that. So that's number one, understanding the relationships between data points. Secondly, graph visualization can help you understand property-based commonalities and vertices and edges. So that's a bit of a mouthful. What I mean by that is that your vertices and edges in most graphs have properties that you define on them. In our graph, it's something like name, label, and age, but it could be risk score, or it could be birth year, or it could be number of favorite singer-songwriters, things like that. And you can use these properties to color your graph or to give it certain highlights so that, yeah, the graph is more easy to understand. So on the right, you can see highlighting that I've done on that sample graph that we have. So I gave different types of vertices and edges different colors. I also gave them icons. And then you can see some of the edges are animated and some of the vertices are flashing. So all these are all things that I can do to make my graph easy to understand. And also it highlights kind of what vertices have things in common, which vertices do not things have things in common, what kind of edges connect different types of vertices, and so on and so forth. And this becomes especially useful when you do multiple queries to your graph and kind of start to get used to your data set. Then you don't have to look at the legend anymore to see, okay, green means place and blue means car. Instead, you're like, okay, there's a car, and Susan and Charles have a car, Philip doesn't have a car, and somehow Central Park is connected to McDonald's, right? And yeah, I mean, you can use that, of course, to highlight. So you can highlight common properties, but you can also highlight uncommon properties. So if you know something is not the way it should be, so maybe if age is greater than 100, you could maybe give that vertex a different color or make it flash so that you know there's a very elderly person, maybe in your use case, that's very important. So we should pay particularly close attention to that specific vertex. Yes, so in any case, these highlights will help you get very quickly a high-level understanding of your query result. No matter what the query you're writing, with these highlights, you will see, all right, this is what's going on. I can now dive deeper into my data set. And yeah, this data or these kind of highlights can also be used when running graph algorithms that modify properties like PageRank. You can give vertices different sizes depending on their PageRank value. So you can see, all right, the biggest vertex is the one with the highest PageRank value. So that might be interesting to check out in my analysis. Cool. So that's number 2, understanding property-based commonalities. Now on to number 3, which is about naturally exploring your data. So this is all great. You know, kind of know the structure of your graph. You know some things that are common or are very uncommon in your graph, but you want to know actually more about what's going on, and you want to dive deeper and understand more. So the first thing you would do is you would look at properties of the different vertices and edges, right? So you can do that by tooltips. So you could right click on a vertex or edge, and the tooltip opens up, and there you can inspect the different properties that are defined on that vertex or edge. So that's number 1, very simple. Secondly, you can actually interact with the edges around the graph query result. So instead of just looking at, okay, I've selected these specific vertices and edges, and just looking at that, you can say, all right, I want to get the next neighbor from this vertex that is not actually part of the query result that I had, but might be interesting for whatever I'm trying to do. You can also get more fancy with it. We have something called a smart expand, where you can give actually some properties and say, get me the nearest vertex that is older than 35. And then it'll try to find the closest connection to a vertex that has age property 35. And with that, you can really dive deep into your data set. Similarly, you can also drop vertices from the visualization because you think they're not interesting or important for what you're trying to do. And there's a bunch more of those interaction capabilities. One of them is grouping. So this is actually really, really important. So grouping allows you to use a property of the graph and move vertices into clusters. So this could be, let's say let's take maybe a country property. you could group all vertices together by their country and say, okay, there's now 13 people in the US for my graph query results and 2 in Germany. You can even, change the size of the vertex, the group vertex, according to how many elements are in there and things like that. So that really helps you clutter the view a little bit and go a level higher and say, okay, what am I looking at from a group perspective? And then we have features like graph, we call it network evolution. So for this, you need a date property or 1 or 2 that signal a start and an end in some sort of way. So let's say it's the date when someone is born and the date when someone passes away. So you can use these properties to animate how your graph evolved over time, in the sense of these people were born, maybe they got married, so a connection appears between 2 vertices. Then one of them passes away, so they disappear. Another one has children, so a new vertex appears. And so with that, as you hopefully can see in the GIF on the right, you kind of understand how things come in and out of the graph. And there's many more ways of naturally exploring your data that we have in our graph visualization. That was number 3, sorry, naturally exploring your data. Now, those are the 3 main benefits that I see in graph visualization. But before we wrap this up, I want to give you some real world examples. So one of them is the financial world. So you can see on the left, I have a data set with customers and their accounts, and customers send money, so they do transactions between accounts. And you could visualize different vertices with bigger size, depending on like a risk property or something like that. And then you could do financial analysis. You see some maybe circular flow of money from one account to the other, and you could try to dig into that. On the right, we have a health science use case where we have patients that go to the hospital, get certain tests and medication, and you can look at kind of your patient's history in that sort of way. By the way, for the example on the left, we have a similar training available that dives deep into how graphs can be used for financial crime analytics. Yeah, that's all I had for you today. In summary, again, 3 main benefits of graph visualization. Number 1, understanding the relationships between the data points. Number 2, understanding property-based commonalities in vertices and edges. Number 3, allowing you to explore your data as naturally as possible. And it's kind of amazing. If you look at these 3 screenshots I have here, they're all the same graph. You have the PGCo result set implementation, which contains all the data just in a programmatic form. You have your blank graph that still tells you so much information about what's going on. And then you have your colored graph, your highlighted graph that when you do it very often, it'll become second nature, understanding what's going on with just one look. That's all I had for you today. Thanks for tuning in, and see you next time. Bye.